Okay, so today I have two power analyzers which I'm going to be doing a side-by-side comparison on. I have the PA3000 from Tektronix and the WT500 from Yokogawa. The Tektronix is priced between £5,100 and £9,500 and the Yokogawa is priced from £4,300 to £6,800. That said, the Tektronix pricing goes to a 4-channel unit and the Yokogawa to a 3-channel, so as a fair price comparison the 3-channel Tektronix is £8,100, which again compared to the Yokogawa 3-channel at £6,800. So what do we get for our money? First, the basic specifications show accuracies at 0.05% basic accuracy for the Tektronix, and that's against a 0.1% basic power accuracy on the Yokogawa. Now this may appear to show that the Tektronix is twice as accurate, yet looking further into the specifications, the Tektronix basic accuracy is for voltage and current only, whereas the Yokogawa specifications of basic power accuracy is for active power. Frequency bandwidths on the Tektronix are advertised to 1 MHz and the Yokogawa to 100 kHz. I know that Yokogawa do have higher bandwidth analyzers, but this is what I've got today. This is what I can compare one against the other with. Input voltages on both units, the Tektronix is at 600 volts RMS and the Yokogawa is at 1000 volts RMS. Input currents, 30 amps RMS on the Tektronix and 40 amps RMS on the Yokogawa. For this comparison, as part of the tests I'm going to be doing, I'm going to be using a function generator. The channels have each got a BNC two-way splitter on each. Just basically means that any individual channel measurement uncertainty can be eliminated as the splitter goes into the corresponding voltage and current inputs on both units. The current measurement though is done as a voltage input into the external current sensor inputs on both units. So first things first, I'm going to default both units to show there's no magical setup. Let that load. Okay, so both units have been set to their default settings. Now, the display on the Tektronix shows each of the 4 input elements. Because I'm just looking at the one, I'm just going to focus on looking at Group A, which will be channel 1, as you'll see across the top. Next thing to do is to set up the auto ranging, which I'll be using on this test or comparison. I'll also set up the external shunts as well. So ranging, voltage, that's on auto, which is good. Current, auto. I will double check that once I've changed the configuration to the shunt. And scaling, I'm going to scale both units. 1 amp would be represented by 1 volt, or 1 volt equals 1 amp. External shunt, 1. Okay. And then just to double check, the ranging is on auto for current. Okay, that's cool. So back out there, onto there. Okay, so 5 volts, 5 amps. Just change the function generator actually. 5 volts, and then the next one. There you go, 5 volts, 5 amps, all set up. Okay, the Yokogawa. That's auto ranging on the voltage and the current. Again, the current setup needs to be done for the shunt, or for the external current sensor input. I'll go to setup, ranges, external sensor. Now here the sensor ratio, it says millivolts to amps, so it wouldn't be 1 millivolt, it would be set as such. So what you see is 5 volts, 5 amps. Same on both units. Same power reading with the power factor displayed there. On the tech unit you can move down and look at more parameters as well. With the Yokogawa unit you can go to form and choose a variety of different formats of displaying more and more data if you want to. Okay, so that's the ranges setup and the external sensor setup. The input frequency at the moment is at 50 Hz. Just to go down here, you can see it on there at 50 Hz. But let's see what effect comes about when we change the frequency on both the voltage and the current separately. Let's see if there's any deviation from one to the other depending on the frequency of the signal. Okay, so we'll start with current to begin with. Let's drop that down to 1 Hz. Again, no change. Let's up that to 1 kilohertz. Not much change on the current this is. And 100 kilohertz, which is the top end range of the WT500. Okay, so on the current you can see at 100 kilohertz the 1 megahertz Tektronix unit has dropped down by just over half an amp, whereas the Yokogawa is held quite strong. I'm expecting the Yokogawa to drop down on the current when I go to 1 megahertz, but then the Tektronix drops down as well, maybe not as far as the Yokogawa, but considering that the 5 amp input across the 1 megahertz bandwidth on a 1 megahertz unit is showing 3.6, we know that high frequency current measurements and voltage measurements do have a greater deviation, but that is quite high. Again, I'm going to disregard the fact that this is showing at half the measured unit, because at 1 megahertz for a 100 kilohertz unit it's not built to perform at the 1 megahertz. Okay, let's reset that back to 50. Now let's have a look at the voltage. Same again, 1 Hertz. Okay, let's go to 1 kilohertz. There's no change there on the top line on the voltage. 1 kilohertz. Okay, no deviation there. 100 kilohertz. Okay, there's no change on the voltage on the Tektronix, however the current has gone up by 0.6 of an amp. Perhaps that's down to the external current sensor input, whether there's any voltage interference. I'm not sure, maybe that's a question for offline. But the WT500 on the measurement has held very strongly on the voltage. And let's go to 1 megahertz and see what happens. I wonder what happens to the current here on the Tech. Bear in mind this is a voltage frequency change. The 500 again I'm going to disregard because it's specified to 100 kilohertz, so 1 megahertz it's not built for that. But my concern here is, yes, it's specified to 1 megahertz and it's 0.1 of a volt, which isn't bad considering it's at the 1 megahertz frequency. But the current input, that's gone up by 1.5 amps. Again, I'm not changing the current here, I'm changing just the voltage. Again, a question maybe for offline, but quite a difference there. Yeah, let's draw that down to 50 Hertz. Again, the current changes again. Okay, so 5 volts, 5 amps, 5 volts, 5 amps. We're back down to 50 Hertz on the voltage and the current at a 5 volts RMS input. Okay, so let's have a look at the input ranges now. So instead of changing the frequency, which we're going to hold at 50 Hz, we're instead going to change the voltage, and then we're going to change the current. We're going to see how low they can actually sense down to. So let's change this down to 1 volt RMS. We're going to look at the voltage first. So 1 volt RMS, both units at 1 volt. Let's go down to half a volt, 500 millivolts. Okay, both units. Let's go down to 100 millivolts. Okay, the Tektronix unit's blanked out, or zeroed out. Where did it zero out at? It's at 0.2. 0.3 at 300. Okay, let's go down to 270. It's there. Yep. 250. Okay, right below that. Okay, so it looks like at 250 millivolts the Tektronix can't measure below that. Okay, it's on a 5 volt auto range as well. Whereas the lowest range on the 500, I believe, is at 15 volts on the screen. 15 volts auto. So let's see how low the Yokogawa can go. 0.1. Let's go to 0.5. Okay, so that's cut off at 0.5. Let's go up to 0.7, 0.8, 0.8. Let's go down to 0.75. Okay, 0.76. 0.75 then blanks after about 1/10 of a second. Okay, so let's go with 0.76. But 0.76 out of 15 volts, 0.076, forgive me, out of 15 volts, that's 76 millivolts out of the 15 volt range. That's pretty good. And now let's have a look at the current and see what changes there. Changes to 1 volt. Not volt, amps. 500 milliamps. 100 milliamps. Yokogawa had to think about it, don't 50 milliamps. 10 milliamps. Both are doing pretty good. About 5 milliamps. 10 milliamps. 1 milliamp. Okay, so the Tek has blanked out again. Let's go to 2 milliamps, 3 milliamps. Okay, so scrolling down to 2.5 milliamps. Okay, 2.4. Okay, so the Tektronix cuts off at 2.5 milliamps. Okay, so how low can the Yokogawa go? It's 2 milliamps, 1 milliamp, 500 microamps, 400 microamps. Bit of a deviation in coming on there. 300 milliamps. Okay, cuts off there, so 300 milliamps. Again, a good range, considering that it's on the auto range for the current input. It's on an auto range on current input for the Tek as well. Yeah, quite a significant difference, as you can see there, on the voltage ranges and on the current ranges as well. Okay, so let's reset this all back to 5 volts, 5 amps. I'll do it the other way around. 5 amps, 5 volts, 50 Hz. Okay. Let's have a look at the scope type display now on both units, which comes as standard. And wave. Press of a button on both, nice and easy to access. On the 5 volt RMS signal that I've put in, which, just to confirm, 5 volt RMS, on the wave it's clipped. so maybe I need to change the range on that. It's on auto ranging, but maybe I need to change the range on that, whereas the Yokogawa, still auto ranging, it shows all of the parameters. One thing to note though, the Tektronix shows a power waveform, or a waveform that represents watts, whereas the Yokogawa doesn't seem to show that. Again, perhaps I've not found that, but I've not been able to find it so far. But this is, considering we're on a 5 volt range and we've input in 5 volts, I would expect this to be a complete waveform rather than clipped. But let's just see if that is the case, or if I've done something wrong. Let's go to inputs and ranging, voltage range. So I'm expecting when I change this to a higher range, 10 volts, I'm expecting that waveform to be complete. Yeah. So in order to show the waveform on the Tektronix, when it's a 5 volt RMS input on the 5 volt range, again the ranges, I'll double check if they're peak or RMS. I suspect based on this that they are peak ranges and not RMS ranges, but nonetheless when a 5 volt is put in for what looks like a 5 volt range, it's clipped at the top of the wave display. Okay, the next function that we've got is the bar function. So if I go onto the bar function on both units, we're going to get a pretty boring display because we're just looking at 50 Hz 5 volt RMS. So I'm going to go on the function generator, change things about a little. Let's change this to a PWF input frequency of 100 kHz. This is on the current, and 20 volt peak to peak, or 20 amp peak to peak. Okay, and then on the voltage, another PWF. Let's keep it at 50 Hz and a 20 volt peak to peak again. Okay, let's see what we have then. So with the Tektronix unit, you can scroll through each of the different types of harmonics: voltage, current, power, and you can display and see the harmonic content from a graphical point of view, a bar graph point of view. Same applies with the Yokogawa. However, we're going up to the 10th harmonic order on the Tektronix, whereas we're on the 50th on the WT500. So let's change this about. There's a button here which has harness, V harmonics. We can change the range. Let's delete that to 50. That's for voltage, and for current, the range. And let's just get that one done as well, so it's all uniform. Okay, now let's have a look. Look at current harmonics. Okay. Okay, so current harmonics, there's loads of harmonics. That's what I like to say. One thing to note though, in order to have a look at the voltage, you need to scroll back through. Same with the current and the power. I've not found a way of being able to change this display to look at all three simultaneously, which would be a nice thing. It is, however, though, available on the Yokogawa. Let's have a look here if I go to try. Okay, so you've got the voltage, current and the power. This unit, however, has still kept on the auto range, and bearing in mind that we're on an equivalent to a 20 amp peak to peak, this has changed the range to 100 amps. So let's bring this down so that we can actually see the harmonic content and match it to the 100 milliamp or microamp. Let's change it down so we can see it. Okay, and one thing to note here as well is because we've changed it to a lower range than what the input is, you may not see, but there is an indicator flashing away at the top to show that you're actually over ranging on that particular input. There's no indication on this unit that there is an over range, so maybe it's auto ranged to that particular range, perhaps. One thing that is a concern though, looking at this, is there's quite sporadic readings on the current harmonics on the Tektronix. The WT500 appears to be more stable. Let's increase the update rate and see if that changes anything. 10 times a second. Okay, so there seems to be a difference, a clear difference in looking at the current harmonics. What would the voltage harmonics show? Okay, so there's, you could say for the argument of scalability, these are the same. They seem to sweep down, and they sweep down on the voltage, but the current harmonics, that's it's a bit of a concern given that there's such a difference. You see spikes in places on the Tek and not on the Yokogawa, and then you see spikes on the Yokogawa that's not on the Tek. Okay, so there's two ways I can think of in looking at this. We can look at the total harmonic distortion for voltage and for current, compare them side by side. Other than that, we then need to look at specs and calibration and basically seeing what each of the units are calibrated to when it comes to frequencies. This is looking at the 100 kilohertz range, the 50th harmonic, and again the same on the Yokogawa as well. So let's go back to the numeric display and let's go back to numeric on here as well. Let's change the measurements. Let's remove all of these. We don't need to look at this stage now at volts, amps, watts, VA. It's quite a list to go through, of which you have to go down one by one. Voltage and current THD. Is there a power THD? Or watts THD? Okay, no, there's individual harmonics. I want to look at THD. So I can't find a power THD. Just amps THD, volts THD. Okay. Nothing that's telling me that there's a watts THD reading on there. Okay. Okay, that's a first, something that's above 100%. Let's see what the Yokogawa says. Now, looking at the Yokogawa screen, OL I would believe would be over range or overload. Again, because of that, the power would also show that as well, I believe. But let's change what's on the actual display itself. Where is it? Much easier to scroll through, by the way, having a list with up and down arrows rather than one big long list. Voltage and current. Okay, and I have also noticed right next door to that the THD for power. Okay, so the voltage harmonics, as I said before with the bar, I'm not particularly concerned about, and you can see from the percentage mark here they're pretty much the same. The current harmonics though is very different, with the Yokogawa being stable around 99.9 total harmonic distortion, whereas the Tektronix for some reason seems to be going a little bit loopy, and this is at 100 kilohertz, so a tenth of the advertised range. It's showing harmonic measurements up to 1000%, which is a first. So I think what I'm going to have to do now is to start looking into specs and start looking into calibration. So let's load that up and see what we can see. So further to the video, I've looked online in search of specifications and calibration, and I found some interesting facts. On the Tektronix, I found that only part of the information is available,
and that the manual contains more information. In addition to this, I've also found that the 30 amps RMS range is only for up to 30 minutes, and if you're looking to make an indefinite measurement, then 20 amps RMS is the limit. Also, I've noticed that there looks like a duplication in the specifications, yet this word typical appears with an extra frequency range from 850 Hz to 1 MHz. And after searching, I found that typical actually means non-warranted. So I understand this to be unproven, else why would this be mentioned? The division of 45 to 850 Hz and then the 10 Hz to 45 Hz and 850 Hz to 1 MHz would say to me that the specifications only apply between the 45 and the 850 Hz frequencies, and this could be a reason why the THD was so sporadic, as it was set to 100 kHz on the current. If the Tektronix though is only proven to 850 Hz, then this is less than 1% of the 1 MHz specification. Finally, peak ranges and RMS accuracies. I suspected this earlier when clipping occurred on the wave graph. Another confirmation of the power accuracy. As I understand though, watts is a unit of active power, which accounts for voltage, current and phase. Yet the accuracy specification here is just voltage and current. So that for me is either apparent or reactive power. VA though is listed underneath, yet it has exactly the same calculation next to it. Although not highlighted here on this screen, the first paragraph is also a strange one. As I understand, their power analyzer has a non-warranted specification for measuring power. Finally, their calibration has no mention of calibrating power anywhere. I've looked through each of the scopes of accreditation, and none of the calibration laboratories on this list have any mention of electrical power. It can mention RF power, but not electrical power. So then I had a look at the Yokogawa specifications, and they are very, very extensive. It takes quite some reading. Luckily though, they have full specifications across all the frequency ranges, and they show the accuracies for power too. Their calibration details are not so difficult to find, and they calibrate to 100 kHz, which is great if you've got a 100 kHz power analyzer. They even provide some sample certificates as well on their website too. Just shows some confidence. In summary of the two units, the Tektronix has the higher channel count and the higher bandwidth than the Yokogawa. The Yokogawa is lower priced by the Tek model. It's also specified to measure active power, has higher voltage and current inputs, which can also measure to lower levels than the Tektronix. Also, the Yokogawa can be calibrated across that full range, where, as just mentioned, the Tektronix is to less than 1% of what's actually advertised. There's also some concerns with the Tektronix around the current reading being affected by the voltage input. Again, that could be down to the external sensor input that was used. Also, the reading on the voltage was to 2% of the range, if my maths is right, but also the current is to 3% of the range, which is another limitation too. Okay, I think that's enough for now, so thank you very much for watching. Until next time.